Hello again, welcome back. So we're looking at solving simultaneous equations. What is that? Well, that's just finding a value of x and y at the same time. If you look at the top equation, we'll call that equation A. We cannot solve this because there are two unknowns. Let's call the other one B. So what we do is we solve them at the same time, hence the word simultaneous. So the first thing you want to do before you do anything is make sure that the x's line up going down the page, the y's line up going down the page, and the answers line up going down the page. Again, x's, y's, answers. X's, y's, answers. If you get the format of this correct, the rest of it becomes a little bit easier. Our first step is to eliminate either the x or the y. So I don't want two unknowns, I want one. So I have to cancel the y's or cancel the x's. If you look at this here, we have got one y and one y. This is a positive one, this is a negative one. So if I just purely look at this, plus 1y plus minus 1y, well, that becomes 0 because a positive and a negative together become a negative. So 1 minus 1 is 0. And that's what I'm trying to achieve. I'm trying to get this to disappear. Well, I've made them disappear. So for this case in particular, I'm actually going to add equation A to equation B. So let's do that. Going down the page, 3 add 2 is 5. 1 minus 1 is 0. 17 plus 8 is 25. Hopefully you can see now we're left with one unknown and we can solve that. Divide both by 5, x is equal to 5. That is our first solution. Step 2 is to put the x equals 5 back into either equation A or equation B. You can choose whichever you want to. It doesn't matter which. I'm going to choose A. So we have got 3 times x, x is 5. 3 times 5 is 15 plus 1y is equal to 17. And now we solve that. Take 15 from both sides. Y is equal to 2. I have now got both solutions. I've got x is 5 and y is 2. Step 3 is just check them to make sure they're correct. So to check, all you do is you put x is 5, y is 2 back into either equation A or equation B. Now, because I used equation A here to find y equals 2, I'm going to choose to put it into equation B. But to be honest, it doesn't matter. You can choose either. So I've got 2 times x, so 2 times 5 is 10, minus y, well, y is 2. 10 minus 2 is 8, and yes, that's correct. So I know that that worked. So therefore, I know my y equals 2 and my x equals 5 are correct. Let's do question 2 in the same way. Okay, first of all, they're lined up. Step 1, do I add or subtract? So in this case, I have got 1x and 1x. If I add 1x to 1x, I get 2x. And then if I add those two, I get 2y. That's two unknowns, so I don't want to add. If I subtract, 1 minus 1 is 0. That's brilliant. That's what I want. No x in this case. I'm left with just y's. 5 minus minus 3 is 8 because a minus and a minus make a plus. 8y is equal to minus 3 minus 13 is minus 16. Let's solve this, dividing both sides by 8. Y is now equal to minus 2. Step 2, we put the value here that we've got back into one of these equations. I'm going to choose to put the y equals minus 2 into equation B. So we're left with x. Now we've got minus 3 multiplied by minus 2 is plus 6. So that equals 13. We solve this by subtracting 6 from both sides. X is equal to 7. So to finish off, I just check by putting x and y into either equation A or equation B. Again, I like to use the opposite one that I previously used. So we've got x is 7, plus 5 multiplied by minus 2 is minus 10. 7 minus 10 is minus 3, and was the answer minus 3? Yes, it was, so I know that they are correct. Last question on this page. In this case, 3x, 4x, we can't eliminate them. We can eliminate these because 4 minus 4 is 0. So in this case, I'm going to take away. 3 minus 4 is minus 1x. 4 minus 4 is 0. 18 minus 20 is minus 2. Divide both sides by minus 1. X is equal to 2. Step 2, substitute that into either equation A or equation B. I'll go straight for A. So now we've got 3 times 2 is 6, plus 4y is equal to 18. Subtract 6 from both sides. 4y is equal to 12. Divide both sides by 4. Y is equal to 3. Finally, step 3, let's do our check. I used equation A, so now I'm going to use equation B. 4 times x, well, 4 times 2 is 8. 4 times y, well, 4 times 3 is 12, and that's plus 12. 8 plus 12 is 20. Did equation B equal 20? Yes, it did. So now I know that they are correct. So this is the start of simultaneous equations. One more page and we're done. If you're finding the video useful, please like and subscribe. Okay, looking at these next 3 questions, you might notice in these cases the x's are different, the y's are different in each case. So we can't eliminate straight away. We have a step to do first. We have to make either the x's or the y's the same in order to eliminate. Let's start with equation A and equation B. We can choose to multiply A by 3 and B by 2, and then we'd have 6x and we can eliminate. Or actually, there's an easier way in this case. We could just choose to make that y 4y and we could eliminate there. So we're going to multiply equation A by 4. So now we've got 8x plus 4y is equal to 60. Now, I want to put a warning here. That's the one that gets forgotten. Okay, carrying on. We have now got equation A dash. You'll notice that I haven't done anything with equation B. It's exactly the same. I've just brought it down. So now back to step 1. Are we adding or subtracting? Well, we need to take away. We are left with 5x is equal to 35. Dividing both by 5, x is equal to 7. There's the first part. Put the 7 back into one of the original equations. I'll choose the top one. 2 7s are 14, plus y is 15. I think it's quite easy to see where y is equal to 1. So there's our second part. Step 3 is to check. I'm going to put it into equation B because I used equation A earlier. 3 times 7 is 21. And 4 times 1 is 4. That equals 25. Did equation B equal 25? Yes, it did. So there we go. They are correct. Okay, so that was just one added step. That was it. Let's do that again for this next one. So if we look at these, we have got equation A and equation B. I'm going to multiply the top one by 3. 3x minus 9y is equal to, don't forget to multiply the 11 minus 33. That is now equation A dash. Just bring down equation B. And now you're back to the original concept of elimination. So I'm going to subtract here because 3 minus 3 is 0. Minus 9 minus 1y is minus 10y. Minus 33 minus 17 is minus 50. Divide both by minus 10. Y is equal to 5. There's the first part done. Substitute the 5 back into either A or B. I'm going straight back to A. So I'm left with x minus 3 multiplied by 5 is minus 15, and that is equal to minus 11. Add 15 to both sides, x is equal to 4. Last step is just to check. I will put x and y back into equation B. So 3 times 4 is 12, y is just 5. 12 over 5 is 17. Did equation B equal 17? Yes, it did. So I know that 4 and 5 are correct. So this last one has one slight complication, is the fact that rather than multiplying one equation to be able to eliminate, you're now going to multiply both, because I need to make the x's or the y's equal the same amount, and I can't do that by multiplying either equation A by a number or equation B by a number. I have to multiply both. I will choose to make the y's both 10, so I'm multiplying that one by 2 and this one by 5. So now I rewrite both of these equations. So the top one becomes 6x minus 10y equals minus 96. Equation B becomes 20x plus 10y equals 70. So that now is equation A dash, and that is equation B dash. So now let's just use the elimination method to finish this off. Getting rid of the 10s, minus 10 plus 10 is 0, so that is a positive. Let's work down the page. That becomes 26x. They cancel, they eliminate each other. That is equal to minus 26. Divide both sides by 26. X is equal to minus 1. There's the first one done. Right, we put x equals minus 1 back into equation A or B. I'll go straight with equation A. 3 times minus 1 is minus 3, and that is minus 5y equals minus 48. Add 3 to both sides, divide both sides by minus 5, and you get y equals 9. Last step is just to check that. Let's put that back into equation B because we've used A. 4 times minus 1 is minus 4. 2 times 9 is 18. Minus 4 add 18 is 14. Is equation B equal to 14? Yes, it is. So I know that that and that are correct. And that is simultaneous equations done. Like I said earlier, please like and subscribe. And the next video is on solving linear and quadratic simultaneous equations. Sounds difficult, but again, if you can do this, the next one is also manageable.